Assalamualaikum. Today we will continue on the properties of the Laplace transform. In previous lesson, we have learned about the definition of Laplace transform. So let's recall back. Laplace transform of ft is actually equal to integration from 0 to infinity, okay, for the function of e to the minus st multiplied by that particular function, okay, multiplied by dt. So we have an example. Let's say we have a constant. So we just substitute the constant into the definition form. Then since it is constant, we can bring out from the integration. Then we just have to integrate the e to the e minus st. Okay, after we get the integration, so we just substitute the value infinity minus 0. Then we get the a over s. Okay, so where the condition is s must be greater than 0. Okay, another example, we have touched about the t. Okay, so to get the Laplace transform of t, we just substitute into the definition. Okay, the t here, we just substitute into the ft here. Okay, so since we have two coefficient here, t and exponent, we need to solve this by using tabular method. Okay, so by using tabular method, we will get the answer. Then we can substitute the value of upper limit and lower limit. Okay, so after we substitute the limit, then we will get the final answer, which is equal to 1 over s square. So if you try to do with another value, okay, another coefficient, so we can find the Laplace transform by using this definition. Based on the definition of Laplace transform, it can be summarized as given in the table of Laplace transform here. So for example, in this first column, we have ft. Okay. So to get the Laplace transform, it is given by Laplace transform of ft equal to capital Fs. Okay. For example, here we have constant. A represented by any constant. So to get the Laplace transform, we will find that it is equal to a over s. Okay, so same goes to the third column. So here, for example, we have exponent at sine bt. To get the Laplace transform, we just substitute value of a and b into the formula, then we get the Laplace transform. Okay, we also have another properties for the linearity, where if we have plus minus, operation of plus minus for two functions, ft and gt, okay, we can simply split both functions, then we can find Laplace transform separately. Okay, so let's go to the example here. Laplace transform of 5 plus exponent 2t. So this is plus, so we can split this one first. Laplace of 5 plus Laplace of exponent 2t. Okay, so Laplace of 5. So 5 is constant. We refer to the table for the constant formula. Okay, so we know that a over s. So based on here, we have a equal to 5. So just substitute the value. So we have 5 over s. Okay, 5 over s plus for the exponent to t. Okay, from the table, we can refer to this formula. So we need to define a. So a in this case is 2. Okay, so substitute into the formula 1 over s minus a. So s minus a equal to 2. We just substitute value of 2. Okay, we go to the next example here. So Laplace of 2t power 3. So 2, we can bring this one out. So we have 2 Laplace transform of t power 3. Okay, so t power 3 is actually equal to, from the table, we have t power n. T power n. So we need to define what is n. N in this case is equal to 3. Okay, n equal to 3. T power n. So we just substitute the formula. We have, I'll copy back the formula first. Sn plus 1. So we will have 2. N is equal to 3 factorial over Sn plus 1. 3 plus 1 is equal to 4. Okay, so in this solution, we have to find what is 3 factorial. So what does it mean by 3 factorial? So 3 factorial means we need to find 3 multiplied by 2 multiplied by 1. Okay. So if we have 4 factorial, it means 4 multiplied by 3 multiplied by 2 multiplied by 1. Okay. It is in decreasing order. We just need to multiply all this. Okay. So we continue. So we have 2, 3 multiplied by 2 multiplied by 1 over s power 4. Okay, when we substitute 2, 3 multiplied by 2, 6 multiplied by 1, then we get 6 over s power 4. Then the final answer will be 12 over s power 4. Okay, we try another example. Laplace of exponent 3t sine 2t. So if we refer to table, it is based on this form. Okay, so first define what is a. So a in this case is 3. Okay, and b in this case is 2. So when we want to we just have to substitute the formula. So in this formula we have b equal to 2 equal over s minus 3. Okay, power 2 plus 2 power 2. Simplify 2 over s minus 3 power 2 plus 4. Okay, so next example we have t power 4 exponent to t. Okay, so this example come from this table. Okay, so define first what is n equal to 4. So a equal to 1. So to find the Laplace transform, we just substitute. I copy this one first. Okay, so that you'll be more understand. N plus 1. So n equal to 4 factorial over s plus 1. Okay, n plus 1, 4 plus 1 is equal to 5. Okay, so 4 factorial is equal to 4 multiplied by 3 multiplied by 2 multiplied by 1 over s plus 1 power 5. Then we have 4 multiplied by 3, 12 multiplied by 2, 24 over s plus 1 power 5. Next, we go to the example of function t power n that multiply with any types of ft here. Okay, from the table, we have this formula. So let's try to do this. So let's say we have an example of Laplace transform of t multiplied by sine ht. Okay, so from the table, we have seen that there is only one formula that can suit for this problem. Okay, where we have t and sine ht. Okay, so to use this formula, okay, so first we need to define what is n. What is n? So in this example, we have n equal to 1. Okay, t to the power of 1. And we also have to define what is ft. So ft here is equal to sine ht. Okay, so in order to get the Laplace transform from here, we can simply substitute the formula here. Okay, I substitute negative 1 power n. So power n is equal to 1. Okay, d power n equal to 1 over ds power 1 fs. Okay, so fs here means that we need to find the Laplace transform of ft. Okay, remember fs is equal to Laplace transform of ft. So what is ft? We have defined the ft just now. So means that to get the fs, we need to find the Laplace transform of sine ht. Okay, sine ht. So Laplace of sine ht is equal to, so in this example, sine ht. So we need to define what is a. A is equal to 1. So we will get 1 over s square minus a square. A square is equal to 1. Okay, 1 square. So 1 over s square minus 1. That is fs. Okay, so we have get for the fs, so let's substitute back. Okay, so the formula is t, I copy that one back, is actually equal to negative 1 d over ds fs, which is equal to negative 1 d over ds fs. In our case, in this example, is 1 over s squared minus 1. Okay, so what does it mean by d over ds? It means that we need to differentiate the function here, okay, towards s. So how to differentiate this one? So what we can do is negative 1, we can bring this one up first. Okay, maybe s squared minus 1 minus 1. Okay, then to differentiate that one, we have negative 1. Okay, so differentiate, bring to the front, so we have negative s squared minus 1, negative 2. Then differentiate the function inside the bracket here. So we will have 2s. Okay, differentiate s squared, we get 2s. Differentiate minus 1, we get 0. Just put 2s. Then, so we will get negative 2s, negative 1 multiplied by 2s, we get negative 2s. So this is minus 2, we can bring downside here, so we get negative s squared minus 1 power 2. Okay, minus minus simplify, we get 2s over s squared minus 1 power 2. Okay. Okay, now let's move to the example where we have any function that multiply with exponent. Okay, to find this kind of the Laplace transform, we have the formula of first shift property, which is fs minus a. Okay, it is shifted to the a value. Okay, so example here we have exponent 2t multiplied by cos t. Okay, so whenever we have any equation, any function, so first we need to define the information that we know. Okay, so for example, this is similar to this formula. Okay, with that any function that attached to exponent. So define first. So in this case, we have a equal to 2. Okay, then any function that attached to exponent is ft. So in this case, ft equal to cos t. Right? So when we have the information, now we can substitute into the formula. So in this formula, we have f s minus a. Okay, to get the Laplace transform. So based on our information, we have a equal to 2. So we substitute f s minus 2. So what does it mean by fs minus 2? We only have the information of a and ft. So in this example, we have fs minus 2, so means, and we have only ft cos t. So the first step is we need to find what is fs. Okay, if we are given ft. So remember, fs is equal to Laplace transform of ft. Okay, so ft here is equal to cos t. Okay, what we have defined just now, cos t. Okay, to get the Laplace transform of cos t, so refer to the table here, we have cos t. So a equal to 1, so just substitute, you get s over s squared minus 1. Okay, that is for fs based on table. Okay, next we want to find fs minus 2. So how we can relate to this form? Okay, I give you an example here. Okay, let's say we have fx equal to x plus 1. If you want to substitute let's say I will substitute x plus 1. So what will happen? We will also change the value of x here to x plus 1 power plus 1. Right? So let's say if we have another function fx equal to x squared minus 1. If I change the function here, x into x minus 1, what will happen? We will substitute also to the x here. Okay, so we have x minus 1 power 2 minus 1. This is wrong. Why? We need to put bracket. Okay, because we substitute x minus 1 into x. So all the value x here is power 2. So all the value x minus 1 also need to be power 2. Okay, so we go back to the example here. This is fs. Okay, fs is equal to s over s squared minus 1. Now we want to change into fs minus 2. So what will happen? So every single s will be substituted with the s minus 2. So we will get s minus 2. Okay, so s here. So s squared. So we will have s minus 2. Make sure put bracket and put power 2 minus 1. Okay. So we get the fs minus 2. We substitute only into the fs. So for the solution, okay, so to get, I just copy this one back, yeah. Laplace transform of e to t cos t. So based on the for table, we have fs minus 2. fs minus 2, we already find the solution which is equal to s minus 2 over s minus 2 power 2 minus 1. Okay, so this will be our final solution.